Hello everybody. Feels like it's been a while, but here is your problem set 7.1 video key. If you would like to listen to a nice soothing song before you get started on this, give a listen to Let Down by Radiohead. It's a great song. You should know the band Radiohead. You probably know a song by them and maybe just don't know their Radiohead. But in any case, number 1, a particle with s of 0 equals 9, so it's giving us an initial position right here, is moving along a horizontal s-axis for 5 seconds from t equals 0 to 5 with this velocity. Determine the position of the particle at t equals 1 and the displacement after 1 second. So remember, position is displacement plus initial position, and displacement is just the integral of velocity. So on this one, we can do the integral from 0 to 1 will give us the displacement over the first second of our function, our velocity function, t squared minus 8 over t plus 1 squared dt. Find the antiderivative of this, which is t cubed over 3 plus, it's not writing very well on this, plus 8 over t plus 1. And you have to evaluate this from 0 to 1, which you can figure out that work, but that will end up being negative 11 thirds. So that's our displacement. I'll just label it as DISP, even though you can't read that. Come on, this is not writing very well. There we go. All right, so that's our displacement. And then position at time t equals 1, you do the displacement over the first from 0 to 1 plus the initial position. So it's 9 plus negative 11 thirds, which is 16 thirds for the position. Again, position is initial position plus displacement. Okay, that's all the things you're finding in this problem are really important to understand how to find them and the differences between them, meaning position, displacement, and total distance traveled. Okay, part B, determine the position of the particle at t equals 5 and the displacement after 5 seconds. So same thing. We're just going to do it at 5. So find the displacement for the first 5 seconds, which is the integral from 0 to 5. I'm just going to write it as s prime, or whatever. I'll write the whole function, I guess. You can just write ds dt in here. But I'll write the function t squared minus 8 over t plus 1 squared. That's actually true on the AP exam, where if they've given a function a name, you don't have to write the whole function inside the integral. You can just write the name of the function, which will save you some time. All right, so same antiderivative as above. Plug in your numbers and you get 35. So that is your displacement. Excuse me. And then for the position, you just do your displacement over that 5 seconds plus the initial position, which is 9, and you get 44 for position. So that's where the particle is. Using a calculator, find the total distance traveled. So that means use Math 9, and for total distance traveled, remember it's the integral of the absolute value of the function. And remember what that does is anywhere this graph happens to go below the x-axis, doing the absolute value of it will ignore that, and therefore it's ignoring a direction change, and all the area becomes positive. And if you're ignoring a direction change, then you're finding total distance traveled. Because when you find total distance traveled, it doesn't matter what direction you're moving. You just want to know how far the particle moved total. So you do the integral of the absolute value, and you just use Math 9, you get approximately 42.59. Now remember, if you had to do total distance traveled by hand, meaning without a calculator, you would have to split it into at least 2 integrals, depending on how many times the graph switches from above to below, and do area above minus area below. So integral, 2 different integrals to find those 2 different areas. And then part D, use the indifferent integral to find the solution of the initial value problem with s of 0 equals 9. So this is like a separation of variables type of thing, except we don't have to separate variables. Although at this point, perhaps when you're watching this, you haven't learned separation of variables yet. but that's what we talk about before you do the AP questions. But in any case, it's solving an initial value problem. So it's what we did on 6.1 together in our notes, like the problem set that has the infamous foot tattoo. But in any case, so we still have, we do the integral. So our function s of t, which is the position function, is equal to the integral. This is not working very well today. Integral of t squared minus 8 over t plus 1 squared. Apologize for the penmanship, but I don't know what's going on with this thing. dt. And so find the antiderivative, and you get, again, the same antiderivative you've already found. T cubed over 3 plus 8 times t plus 1 to the negative 1. I'm going to write it that way this time for no reason in particular. And then plus c. Plug in your initial condition, which is when t is 0, s of t is 9. So you get 9 equals, do it right here in yellow, I guess. So you end up with 9 equals, when you plug in 0 right here, that's gone. Plug in 0 here and you just get 1 times 8. So you get 9 equals 8 plus c, which means our c value is equal to 1. And then you just plug that c value in to the green thing that you already found, and that is the answer. So s of t is equal to t cubed over 3 plus 8 times t plus 1 to the negative first plus 1. All right. Number 2, a car is moving with an initial velocity of 5 miles per hour. With an initial velocity of 5 miles per hour, accelerates at a rate of 2.4 t miles per hour per second for 8 seconds. How fast is the car going when 8 seconds are up? So same question, except now you're finding change in velocity. Remember, to find the amount of change of anything, you integrate its rate. Well, the rate of change of velocity is acceleration. So we do the integral of acceleration from 0 to 8 to find the change in velocity. Oh man, I do not know what's going on with the writing. And then add in the initial velocity. So the integral gives me the change in velocity. Add the initial velocity. And so the antiderivative of this is 1.2 t squared. And then we're adding that constant of 5 at the end. Evaluate this from 0 to 8. And you get 76.8 for your integral value. Plus the initial condition 5 equals 81.8 miles per hour. Notice how I wrote the plus 5 in every step. Because if I just write an integral here and then like do the antiderivative here and then put an equal sign and put 76.8 plus 5, that would actually be a false statement. So you got to make sure, like when you're adding this 5 in, that you don't put an equal sign when the plus 5 wasn't here or here. That's actually something that a grader, an AP grader, told me was really important. Because if you don't do that, then you're not actually writing a true statement. All right, how far did the car travel in feet during those 8 seconds? You can use a calculator for this one, which means we can just math 9 it. So if you do the integral, if it'll let me write, come on, there we go. Integral from 0 to 8 of the absolute value of v of t. Oh my goodness, all right. Let's try to adjust this, all right. V of t dt. Sorry, that looks kind of weird. So our velocity function, though, is really, from up here, it would be 1.2 t squared plus c, and then you can plug in 0 and 5 to get your c value, which does come out to be 5. But you do have to find that c value if you want to use the velocity function to integrate. So you get the integral from 0 to 8 of 1.2 t squared plus 5 dt. Now I dropped the absolute value because this function is always positive anyways, but you can leave it in there and you can just do math 9 of that. And you get 244.8. Now remember, when you do an integral, you're calculating areas, and so you're multiplying units together. Our first unit, like the velocity unit, was miles per hour. So right now we have units of miles per hour, and then the time was measured in seconds, so it's miles per hour times seconds, which of course is not a value that makes much sense to us, so we got to convert these units. And we know that there's 1 hour, so multiply by 1 hour and 3,600 seconds to cancel out the seconds and the hours, so those will both cancel, right? We have an hour on the bottom and top and seconds on the top and bottom, so those will be gone. She gone. And then convert miles to feet, so that you should know that there's 5,280 feet in 1 mile. And so our miles cancel, leaving us with just a unit of feet, which is what we want. Multiply that all together, and you end up with 359.04 feet. All right, number 3, you're given the rate at which millions of bushels of potatoes were consumed. So you're given a rate, and you're asked to find how many bushels were consumed. And so to find the change in something, you integrate the rate. And so the trick on this one, though, is it says how many bushels were consumed from the beginning of 1972 until the end of 1973. That would be 2 years total. This is year 2 until the beginning of year 4. So your balance has to be 2 to 4, which that's a common mistake people make. So we can do the integral from 2 to 4 of, I'm just going to write c of t down here, which is the function, which equals, so the antiderivative is, for the constant 2.2 is just 2.2t. And remember, if it's a power function, it's going to be 1.1 to the t divided by natural log of 1.1, because when you do the derivative of something like this, sorry, an exponential, I said power function. When you do the derivative of something like this, you have to multiply by natural log of 1.1. So remember, it's a to the u times natural log of a for the derivative. So when we do the antiderivative, we must divide. And we evaluate that from 2 to 4, and you get approximately 7.066 million bushels of potatoes. Million bushels of potatoes. Excuse me. All right, these two questions are pretty much the same questions, just different functions. So when is a particle moving right, left, and stopped? So we want to know, it's kind of a sign chart analysis here. We want to know when the velocity is positive, negative, or 0. And so it's moving right when the velocity is positive. So our velocity, so we'll do moving right. If it will actually write, oh my gosh, this is very frustrating. All right, so it's moving right when 3 cosine of t is positive, which is our velocity, which is when cosine is positive, which you should know is from 0 to pi over 2. So it's in quadrant 1, well, it's in quadrant 4 also, but that goes beyond our given interval. So starting at 0, and to pi over 2. I have it closed on 0 because that's an endpoint of a closed interval, and then open on pi over 2 because that's the moment it changes. Depending on what textbook you actually look at, they might close both of those. I always leave it open if it's where the velocity is 0. So left is when your velocity is negative, which you should know cosine is going to be negative in quadrants 2 and 3. So it's going to be pi over 2 until 3, again closed on the endpoint. And then it stopped at just pi over 2 over that whole interval, which is the only place cosine is 0 between 0 and 3. Remember, cosine is actually 0. Excuse me again. Cosine is actually 0 at 3 pi over 2, but 3 pi over 2 is bigger than 3. In fact, we're only in quadrants 1 and 2, aren't we? Because because pi is where it would change, is where cosine would change again, which is 3.14, if you think of unit circle. All right, find the particle's displacement for the given interval. So displacement is just the integral of the function. So we do the integral from 0 to 3 of 3 cosine t dt, which is, remember that constant just stays there when it's a multiplier, so 3 sine t from 0 to 3. You can use a calculator to get the decimal equivalent here, 0.4234 meters. Those aren't unit circle values, so you would need, well, when you plug in 3, it's not. And then total distance traveled. Now, without a calculator, you split it into two integrals. We already know that it changes direction at pi over 2 because you found that in part A. So you do the integral from 0 to 3. Now, if you were going to math 9 it, you just math 9 the absolute value to get the total distance traveled. But to do it by hand, which sometimes you're going to need to do, you need to know that you split this into two different integrals. 0 to pi over 2 of 3 cosine t dt. Pi over 2 because that's where it changes direction, which means the velocity curve is changing from above the x-axis to below, or from below to above, but we already determined that it was moving right from 0 to pi over 2, so we know that the derivative graph is positive, meaning above the x-axis. So split it into two integrals, do each antiderivative and plug in your bounds separately. Combine those two numbers and you get 5.58 meters. Not sure why that one's not rounded 3 decimal places, but it's not worth the time to go through and do it. All right, so number 5 is exactly the same question. I'll save you guys a little bit of video time, and you can look at the handwritten key, but you're going to do the exact same thing. It's literally the same 3 questions, just for a different function. So I'll save you some time. You can just look at the explanation of number 4 as you do number 5 on this video to get the idea behind what you're doing, and then you can figure out the math yourself, or look at the handwritten key that's always available. See ya!